Agents are everywhere, and they can plan your trips, and they can book flights, they can even manage your calendar, and of course, they can respond to emails while you're on vacation. So they give us a lot of, uh, they have made our lives very easier today. But if this same very agent look at our email history and expose it to the internet, that will be a catastrophic failure. So it's very important that from the day one, we think of how we govern these AI agents and their access to our business systems. So Geeks gave me a good introduction about who I am, and today I'll be discussing about how we can secure our agentic systems and what are the key areas that we should be thinking about when we are building AI systems from the day one. So to start with, anyone in this audience familiar with this Twitter thread that happened just over a week ago? And it talks about Replit agent deleting entire production database. Anybody followed this thread? I think there are some of the people in the audience has gone through it. So the interesting thing is that at the very first, the agent was playing innocent and saying that the system was working properly when you last logged in, and now it seems that there's no data in the database. And when agent was confronted, then the agent confessed that, yes, I deleted the entire database because I panicked. So that even the agent was asked not to delete it, and it was given instruction to only to do some other operations on the database, but it has done this, it has somehow gone and deleted the database. So these if the agents are operating without proper IAM, these security risks and these catastrophic failures are very real today. So the agents can get access to unauthorized data, even they are not supposed to look at them intentionally or unintentionally. And there can be privilege escalations like a marketing chatbot if suddenly get access to the financial data, and that chatbot can present it into the internet. And the actions that are done by agents might not be properly tracked in the backend systems. And of course, there can be bad actors impersonating and hijacking these agents so that they can get into the business systems and attack the system through the agents' interfaces. And of course, there are a lot of regulatory compliances and governance requirements are arising. And if you don't employ these proper identity and access management principles and security from the beginning, it will be hard for you to incorporate them later. And of course, you can end up being fined as well. So at the heart, the problem that we have is nothing new. So it's something that we have already solved for the humans. So it's, in very basics, it's who you are and what you can do. And it's already a solved problem for the humans. So in terms of authentication or identity, it's about asking, are you the friendly agent that's assisting me with planning my trip, or are you the malicious actor? And then when you identify the agent, then it's about what you can do. What are the APIs, what are the data, what are the systems that this AI agent can access. But this challenge is very different today because we are working with AI agents who's executing in machine speed, and they have their own brain, and they can reason, and they can do they can perform actions on top of our business ecosystem. So we are not starting zero because there are the identity and access domain is been there for very long. And in previous section, Janas discussed what are the existing standard and what are the communities around that. So there are existing IAM, identity and access management concepts that we can adapt today. For example, we can use a service account to give a basic identity to an agent. But service accounts comes with a lot of privileges. That means like agent can be overprivileged uh, with permission that it doesn't need to do its job. And of course, this is a common practice today that you embed a API key. You get, for example, you get the GitHub pad and put it into the VS Code, and then you work so that API agent works on the borrowed keys. But in execution, it's very hard to map which agent got which key, and also we have to rotate these keys. Also, so in terms of managing these API keys or tokens, it's very hard. And of course, you can naturally fit an agent to an application, but there are technologies like browser use agents, computer use agents, like they can browse through the web UIs, and then they can click through and log into and interact with the existing applications. So they are more like human users in the web today. So, and of course, there are a lot of protocols for delegated authorization and granting permissions for agents when they are acting on behalf of users. But those existing IAM solutions and these standard fall short in sometimes. And of course, I'm not saying we should be totally discarding them, and we should be using them wherever possible. And also, there might be places where we need extensions and places where we need brand new solutions. Let me give you an example of a case. I want my AI assistant to give access to my email and calendar to schedule a meeting. So we can use standard authorization code flow, where I prove my identity to the authorization server, and then the authorization server validates it, and based on the required scopes, it will issue a token to the AI agent. And then AI agent will present that token to the email and calendar APIs and do the necessary scheduling. It will work because it's very proven standard for delegated authorization. And as the user, I am in control. I am the one who granted permission. And I can revoke it at any time. And I didn't share my password with the agent, so that agent can only use that token during the course of period of its lifetime. But it creates an audit nightmare. So in the backend logs and traces, there's no distinction between me going and scheduling a meeting and my agent doing it. So logs will be identical, and if this agent has made a scheduled erroneous meeting, or immediately after the initial meeting, if it has scheduled some other meetings and sent out emails, so there's no way of identifying that it was done by me or my agent, and everybody who got the wrong invite will definitely blame me for sending it out. So at WSO2, when we were looking at how we solve this problem for AI agents and properly govern their access to the systems, we thought of several key questions. So one is the identity question. So who is this agent? What are its attributes? What's the underlying AI model? Because based on the underlying AI model that the agent is using, the behavior might be different. And what's the purpose of this agent? Likewise, there can be different attributes that's defining this agent's identity and identity. So it's similar to users. So as humans, we have a set of attributes, and agents have different set of attributes. And next, access control. So what systems or tools this agent has access to, and what data it can access, and most importantly, what operations the agents can do on top of this data. And when the agent acts on its own, and when the agent acts on behalf of another entity, user, or an application, or even another agent. And there are accountability question. So who's responsible for the agent? So when, as enterprises, when we are employing agents in our system, it should be a well thought decision that where we bring in this agent and what are its boundaries. And there can be a person or a team or a department or organization as it is that's responsible for the agent's activities and at the end of the day. And then how do we audit this agent's behaviors, what it did and when. And the third thing, and of course, how we ensure the compliance. Like there, so nowadays there are no like there are emerging regulations similar to the ones that we had for user data protections like GDPR and so on. And governments and regulatory bodies are actively working on ensuring that AI agents behave within its expected perimeters, and businesses build agents and use AI responsibly. So considering all of these uh, uh, problems and answering those questions, we at WSO2 we are introducing uh, agents as first-class citizens. So we treat them, we give them unique identities in the system. It's not a user, not an application, not a workload, or not an API key. So they will get their own identity and they will be treated as first-class citizens in the business ecosystem. So as an analogy, think of it uh, as you onboard an employee. So when you onboard an employee, you will do a background check, and when you decide to bring that employee into the system, give that person employee ID that's uniquely identifiable. And then you will be issuing a access card for that agent, that employee, and that access card will come with access to different doors, and it may have uh, person who is in the engineering team might not have access to the server room. So likewise, uh, that ID will give you set of permissions and actions. And then this badge is temporary and it can be revoked if someone tried to misbehave, or even if someone stole the badge, it can be revoked. And even when the employee resigns, that all the permissions that were allocated to that employee will go away. So similar concept for the AI agent, but in machine speed and uh, in the lifespan of agents activity in the system. So what are the capabilities that our platform has? So as I mentioned earlier, the first thing is registering agents and managing their life cycle. So each and every agent will get a unique identity, unique identifier in the system, so that you can refer to it in within the perimeters of the business, as well as if it's accessing external services, that identity can go there as well. And then issue credentials so that these agents can prove themselves to the system that it's the agent that it's saying to be. So these credentials are different from humans, because I can have a biometrics and fingerprint, but piece of software can't. Those credentials has to be like private key JWTs, mutual TLS, or verifiable credential or something. And we are gradually onboarding different types of credentials for the system as well. And then most importantly, access controls for the agents. So you can assign agents into the different roles of the system, or else you can govern access based on the attributes. So if agent version 1 may have access to application 1, 2, 3 only, and agent version 10 may have application to 10 another, access to 10 another applications. And one of the most things is about audit. So we enable the capability to audit these actions by adding agents information into the tokens that's going in the wire. So at the every access point, these gateways or the components that are checking, validating the tokens can look at that token and identify this is an agent and add a log or audit trace, as well as use it to add additional policies and governance on top of that, by being able to identify that this is a request coming from an agent. So let me walk you through a simple example, which is an hotel booking assistant. And I can interact with this hotel booking assistant to discover a hotel and check availability and do a booking. And as a value addition, this particular hotel system, which let's call it Asgardeo hotel system, is able to build a personality profile of me. So over the time, it will look at what are my preference, who I am traveling with, and my language preferences and all those kind of things. And based on that, there's another service that the business is offering, that they will assign a individual contact person on site as my concierge during my stay. So, so at the description level, the story is very simple. But if you look at the architecture of this solution, so there are several components. So of course, there's a user-facing interface, and user can directly go to the website, and as a regularly what would you do is to navigate through the website and fill the form and all, and do the booking. And also have the option to go talk to this assistant agent, which is coming form of a chat. And then you interact with the agent in natural language, and agent will use AI model to navigate through that discussion and use the business APIs to do the booking, plan my booking stay and do a booking. And then there's another ambient agent, which is what let's call a staff allocation agent. And that agent is looking at these bookings, and that agent is building this person, looking at this personality profile of me. And then based on that, it'll find the best concierge that it can assign for me. And it will update the system and update the booking by allocating an available staff member for my stay. So let's see how we can secure this agent interaction. So in the previous diagram, there are a lot of lines going from web application to agents, agents to backend services, agent to AI models, and let's see how we can secure them. So in Asgardeo, we have a new section for managing agents. It's very new and recently onboarded. And here you can see I have registered 2 agents for my case, and there are I have given display names for those agents to identify them, like when I manage them. And then each and every agent has a unique ID. You can see it here. And if we go more into the details, I'm not sure whether it's visible at the back, but these are attributes, like what's the underlying AI model, what's description, and if it's expected to be discoverable through the internet, what's its URL. And of course, you can customize these set of attributes that you want to know, maintain about the agent, and then can have manage credentials. And in terms of access level, so one example is role-based access control. So I have put roles of both staff management agent and Asgardeo assistant agent. So assistant agent doesn't have any other permission than everyone. So everyone is just you don't need any set of permission, so if you can weave hotels and so on. But the other agent has hotel admin role that comes with a lot of permission for look at the staff data, staff information, look at the personality profile, and update the bookings. So another important thing is that this booking assistant agent doesn't have permission of itself, but at the runtime, it can do the bookings for me. So that means it can borrow, or I can delegate permissions to this booking assistant just in time, just enough for that particular action. So what happens in the runtime is that when the user is directly making a booking, it will take a, it will obtain a user token and use it to use it to connect to the system. And then when agent is acting on its own, we issue a token for the agent with the permission required for the agents and pre-granted and required just for this particular task. And when the when applications are making requests to the agents, then there will be traditional application tokens. And this is a special type of token that we introduced, which is called OBO token. So that token is given to the agent to work on behalf of the user by user's delegated authorization, and it has information about who is the user and what application is trying to access and what's the agent that trying to do this action. And in terms of identities, there are different identities in the representation: users, applications, and then now new types of entity, agents. And we have built this solution on top of existing standard. We have used SCIM, which is very commonly used standard for onboarding users and managing their lifestyle. And we are using extension for SCIM to represent agent as a new resource type. But that means like you can use existing provisioning infrastructure with minimum changes to manage and govern these agents in the system. And then we have used extension on top of OAuth and OID, OpenID Connect, so that the transports stays the same and there will be some additional information going in the wire, or as well as some additional information added to the token. So that means our solution will only do very minimum disruptions or require very minimum changes to the existing infrastructure, and it will fit. It can be easily integrated to secure your agents and agents along with other infrastructure components. And having said that, Geeks also mentioned that I am part of this global community who is working towards defining standards and finding solutions for agentic AI. And this domain is very new, and agents have been involved to greater extent within a very short period. So therefore, every IAM vendor out there is looking for a solution, and I'm quite glad that as a global community, regardless of from which vendor you are coming from, we all get together and try to find a solution and enhance existing standards for the agentic identity. So there's this MC model context protocol OAuth working group that's defining authorization for model context protocol transport, and very recently there was a we formed a OpenID Connect artificial intelligence identity management community group, and we are key contributors there, and we have started a lot of interesting discussions there, and that's going very that has very good progress as well. And then there are a lot of internet standard drafts and proposals are coming out by different people in different aspects of securing agentic AI. And we also have proposed a solution for on behalf of Float, so the token that I mentioned earlier. So that's an extension on top of OAuth to grant consent and authorization dynamically for agents. And we have got very good feedback from the community and identity experts on this proposal, and soon we will be submitting it to a working group and discussing it there, whether we can make it a standard for everybody to use. So all in all, thinking of security and identity access management for agents from the day one, and not thinking it as an afterthought is brings you transformative benefits. So in terms of, so you don't have to compromise security for the benefit of business. So you can build agents today and securely so that they will not do harm tomorrow. Thank you very much.